Hey guys, welcome to 7.3 on your e-learning today. Hope you're enjoying your time off. This is actually a very simple assignment. You already know how to do it, but I'll go through and do a couple examples just to make sure that we're on the same page. What it is today is that you're proving that your four-sided figure is a parallelogram. So you have all those theorems from last week, excuse me, where you have opposite sides being congruent and opposite angles being congruent. And then you also had the diagonals bisecting each other. Well, if you can show that you have opposite sides being congruent, or that you have opposite angles being congruent, or that the diagonals bisect each other, then you can say that you have a parallelogram. So on today's assignment, they're showing you a quadrilateral, a four-sided figure, and you have to prove that it's a parallelogram, meaning they're going to show all the stuff and you got to say, these things are equal on opposite sides, so therefore this must be a parallelogram. So we're going to do some examples here in a minute from the actual assignment, but there's two other ones on here that we need to look at. And if you have, on the first one right here, if you have two opposite sides that are parallel and the other two opposite sides are parallel, then you have a parallelogram. Okay, so I'll draw one where these two sides are parallel, but this is definitely not a parallelogram. That'd be a trapezoid. So you have to have both pairs of opposite sides being parallel. Otherwise, it's not a parallelogram. Now, number 4, show that one pair of opposite sides are congruent and parallel. So let's say I don't know anything about these two sides here, but I do see that the top and bottom are both congruent and they're both parallel. So opposite sides are parallel and congruent theorem. So if you can show that you have the opposite sides being parallel and they're both congruent, the exact same sides, then you know the other two sides have to be congruent and parallel as well. So those are the two new things that you have in this section. So let's go ahead and get to the assignment, and I'll do a couple things just to show you that you already know what to do. All right, so here is your page in your book. You're supposed to do 3 through 22 all. So I'll do a couple of these even ones with you. And remember, you're required to look at the odd answers before you turn everything in tomorrow. So let's take a look at number 8. On number 8 here, we see that this diagonal is bisected right here in the middle, and both sides are 6 units long. And then we look at the other side, the other diagonal, and it is also bisected in the same spot, and its segments are both 4 units long. So this would be the diagonals converse theorem that we have, parallelogram diagonals converse theorem, meaning that if you can show that the diagonals are bisected, then it is a parallelogram. So when it says to state your reason why, make sure you look at those theorems and say the right thing. But you already know what they are, so if you're proving that something is a parallelogram, all you got to do is use those theorems that you learned last week and just put converse at the end of them. Okay, so on number 8, it does say state each theorem you can use to show that the quadrilateral is a parallelogram. Okay, so let's go down and let's look at something new. Number 14. Number 14 is one of the new theorems that we were talking about. Opposite sides being equal and parallel. If they are equal, then the whole thing is a parallelogram, and we know that this side is going to be equal to that side and parallel. All right, so we need to find a value of x that makes those two sides equal. So just like last week, all you got to do is set them equal to each other. So 2x plus 3 equal to x plus 7. And then just solve it. And whatever you get for x is what you're going to say that you would use to show that they're parallel. So nothing's changed from last week, except you have to find the correct answer here. So if I subtract x to the left, on the left side I have 1x. If I subtract 3 to the right, I get 4. So if x is 4, then the opposite sides will be equal, and we already know that they're parallel. So now I know that it is a parallelogram. So nothing has changed from last week. On 17 through 20, you're just going to have to make a graph and show that they're parallel somehow. Parallel and the same length. So you may have to use the distance formula, but to show that two lines are parallel, they have to have the same slope. So I'll go ahead and I'll do one of these on a different page here, just to show you. I'll do number 18. Let's do, I think these are all fairly simple. I'll just do number 18 on the next page. Okay, so here we have number 18, and I've written down the coordinates. So let's plot them. Negative 3, 0, 1, 2, 3. Negative 3 zeros here. Negative 3, 4, 1, 2, 3, 4. So this is E, and this is F. And G is at 3, positive 3, negative 1. 1, 2, 3, negative 1. And H is at 3, negative 5. 2, 3, 4, 5. All right, so I'm going to use some straight lines here to connect these, and we'll see if we can make it look just right. Okay, so I used some straight lines here to make it look a little bit nicer. All we have to do is show any of the theorems that we've been using. Show that both sides are equal in distance. And if I go from F to G, that's a diagonal. I'm going to have to use the distance formula. So just in case you wanted to do that, and everybody's supposed to be able to do that, the distance formula is x minus x squared plus y minus y squared. And you will have to do this at some point. So there's your distance formula. So you would have to show the distance on all four sides. So FG would have to be congruent to EH. EF would have to be congruent to HG. We could also draw diagonals and do the distances there, find the midpoints, and that just is a lot of work. I think what we should do is show that EF is equal to HG, because those are vertical lines and we can count, but we can't just show that EF is equal to GH. We'll use the new theorem that says that EF is also parallel to HG. And how do you show parallels? You show their slopes. So just in case, slope is also rise over run, or it is y minus y on the top and x minus x on the bottom. So you'd have to do that for both EF and HG. But we do know that EF and HG are parallel because they're both vertical lines. So vertical lines are parallel. So you could just say that for EF and HG. Now we need to know their distances. So since they're vertical, we can just count. So let's go ahead and count from F to E. So 1, 2, 3, 4. So EF is 4 units long. And let's count from G to H. 1, 2, 3, 4. And 4 does equal 4. So this would be opposite sides and parallel and opposite sides congruent theorem is what we would use. Okay, so parallel and opposite sides congruence theorem. Okay, and that's how you do those. So good luck with that. And I'll answer any of the really difficult questions you have tomorrow. Please do as much of it as possible. Let's go back. Let's see. I'm pretty sure it's 3 through 22 all. And it is 7.4 in your book. Page 381 and 382 is where the last two are. All right, so good luck, and I'll see you guys tomorrow. Sorry, that's 7.3. The page is right. I apologize, I wrote down the wrong section. So 7.3, page 381, 3 to 22 all.